May I request the chairman to introduce next speaker, Dr.
Now the quorum is full.
Thank you, sir.
Thank you. Now, next speaker, Mr. Dr. Dinesh Keskar. Everybody knows him as the Boeing man in India. Known as the one of the stalwarts in the Indian aviation industry, Dr. Dinesh Keskar, Vice President of Boeing International and President of Boeing India. He's been associated with the India's aviation progress for the last 2 decades. Dr. Keskar is focusing on mentoring and building key partnerships with Indian industry in the field of manufacturing, technology, defense, engineering, IT, etc. Other than his profile in India, he works relentlessly in building India's profile in the US. He has lobbied with the people in the US to ensure that India gets the nuclear deal. As a part of several associations related to India, he plays a significant role in influencing the developed world in the importance and opportunities that India can offer. From August 2004, Dr. Keskar has served as Boeing Commercial Airplanes Vice President of Sales for South and Southeast Asia. He was responsible for marketing all types of aircraft owned by Boeing to customers worldwide and managed all commercial airplane sales activities in India. Dr. Keskar has served as President of Boeing Aircraft Trading until March 2005. As a part of his contribution to grow the Indian aerospace infrastructure in the last 2 decades, Dr. Keskar has struck 6 deals for commercial planes, the biggest of them being the $11.6 billion order from Air India for 68 aircraft in 2006. Dr. Keskar also influenced his management to partner Air India in building MRO site in central India, Nagpur. And as we all know now that Nagpur, it has changed the economic and infrastructure landscape of central India, bringing progress and prosperity to central India. Dr. Keskar spends a significant amount of time inspiring students in various colleges, including Tier 2 and Tier 3 cities. Dr. Keskar's childhood was in a small town in Amravati, where his middle-class upbringing taught him the value of education and determination for achievements. Holding on to that dream, Dr. Keskar finished his engineering at NIT Nagpur and did his Ph.D. in aeronautic engineering from NASA. He got the opportunity to be mentored by his childhood hero. I believe he hero worshipped Neil Armstrong. Boeing identified Keskar and then he joined Boeing as an engineer, where he contributed significantly to Boeing engineering with his work on 757 and 767s. Dr. Keskar developed the techniques to conduct flight tests and analyze flight test data to obtain airplane mathematical models for 737, 47, 57, 767 flight simulators. As a part of Boeing Executive Leadership Program, he has handled many functions: sales, marketing, finance, accounting. He completed the MBA subsequently and got into marketing and sales in 1987. He was chosen to handle India as a market. So a lot of things happened after he took over that position, and he has signed the first agreement of 4 aircraft in 1991 after being a success stories. And he has also sold aircraft for Jet Airways and SpiceJet. Dr. Keskar has served on several boards and organizations, including National Board of Directors of American Society of Engineers of Indian Origin, Chairman of AMCOM India, Chairman of FICCI, and also in the Industrial Civil Aviation Committee. He is in the Advisory Board of College of Engineering, University of Cincinnati, US, India Business Council Board Member Emeritus, and is a Fellow of Royal Aeronautical Society, Associate Fellow of AIAA, and from 2003 to 2007 is a member of Board of Directors of International Society of Transport Aircraft Trading. Dr. Keskar remains an active member of Indian community organizations in the United States. And in 1999, Dr. Keskar was honored with the Distinguished Alumni Award by University of Cincinnati. In 2006, he received Outstanding Achievement as award from American Society of Engineers of Indian Origin. In the 15th Biennial Convention of the National Federation of Indian American Association, he won an award for meritorious achievement recognized stature and conspicuous success in engineering. Vocational Excellence Award 2008 and 9, instituted by President's Enclave, an organization of 16 Rotary Clubs of Nagpur, conferred Dr. Dinesh Keskar in Nagpur. So here is Dr. Dinesh Keskar. I request you to address. Yeah.
Mr. Chairman, thank you very much for this generous introduction, and my panel members, distinguished minister, and many distinguished members of various services of Indian Armed Forces, distinguished scientists. I'm sure there are many fellow students and other people in the audience. Thank you very much, and I want to thank you, the Aero India seminar, for inviting Boeing again for doing this speech this afternoon. I want to apologize. I was late because of the various things, including the closure of the airspace, because I was flying in from Delhi. This morning I had a commitment I couldn't get out. Secretary Locke, as you know, is in India right now. We had a meeting with him early morning in Delhi, and I'm sure you know he'll be coming here tomorrow and spending some time. But let me get on with my presentation. So if you get the slide on. Perfect. Okay, and we'll get in the presentation mode. Okay, perfect. Thank you. Okay, so I'm going to talk about technology is central to the future of aerospace. And I was listening to Mr. Anand Mahindra, who really talked about technology offsets and other aspects of what is key and central for partnerships for India to make the next step and the next leap into the global world of aerospace. And I totally agree with him on the collaboration, partnerships. That's what Boeing is doing in India. And I'm going to give you a flavor of just the general role of what really technology is all about. So clearly, innovation is key for any company. And what this slide depicts is many things that Boeing is involved in. And clearly, everybody knows the Dreamliner is one of the high technology product that is going to come to the world this year and soon to India also. But on this slide are many other advances in space. On the right-hand side on the top is the blended wing body, the X-48B. These are all the technologies of the future that Boeing is involved in, but Boeing isn't just doing it by themselves. Even a company of that size is doing it globally in the mode as partnership. So technology has been integral to really the development of aerospace products. And the four key areas that are absolutely essential for us to succeed in the aerospace technology are materials, and I'm going to talk a little bit about it because we're doing a cooperative project right here in Bangalore with NL, electronics, computers, and manufacturing processes. But what we are doing in space and aviation is also finding its way to our day-to-day lives, such as the overnight package delivery. It's possible because of the advent of airplanes. Without that, we won't be able to get overnight service from, say, within the United States or within India for that matter. Internet, which started out as ARPANET at MIT, has become now a household thing that everybody in the villages also works with internet, and that's the advent of technology that is helping us. GPS, created by US Air Force. Even every car nowadays in the United States, if you want to go from place A to place B, you punch in your destination and it pretty much tells you where you want to go and how you want to go. Not to forget the how the military uses GPS for its activities. And then the live TV broadcast in the airplanes, everywhere that we go, the live broadcast, perhaps this morning from right this hall to the rest of the India was only possible because of the satellite broadcast that was happening. So all these technologies that are happening globally are really helping day-to-day lives, but also taking aerospace aviation to the next level. Now, as I was mentioning, technology innovation is a team sport. It isn't a right or it isn't a prerogative of any company or even a country anymore. It is all done jointly and globally. And couple of examples here that you see is the one that truly is several countries involved is the International Space Station, which I'm sure you're familiar with. It's really doing great strides, but it is only happening because of many countries getting together and putting its resources together, because technology invention, as I will show you in a minute, is not inexpensive also. It takes billions of dollars to do it. And I already talked to you about the X-48 blended wing body, which we're working with NASA and US Air Force, and then Pratt & Whitney and Boeing is working on X-51 Wayrider. These are just some of the big projects that are happening around the world, which shows how technology collaboration can work. But as I was mentioning to you, and I won't read all the numbers, R&D is a global phenomena, and over $1 trillion is being spent worldwide on R&D, and you can see how geographically it is distributed. But United States and Asia each is spending over $300 billion in advancing technology, which is really giving us new products, whether it's mobile phone, whether it's your iPhones that are in your hand, or Blackberries or everything. All these new technologies are coming because of the R&D investments that is being done around the world. Now, at Boeing Research and Technology International, we have already adopted that, and we are working in Spain, Australia, and our BR&T center is right here in Bangalore, in RMZ Infinity Center in the Old Madras Road. And we also are working with Russia and China, because clearly, as I mentioned on the previous chart, a lot of countries get involved, and we are doing what is called a collaborative development of technology. And here is an example of an environmental research. I'm sure you're familiar with the fuel cell demonstrator. Everybody is talking about carbon emission. If you attended one of the international air transport meetings, there was a challenge thrown to manufacturers like Boeing that can you, in the next 50 years, produce an aircraft that does not produce any carbon emission? Tough one, okay? I don't know how we get there, but clearly, if you look at this little airplane that was flight tested with Boeing and other folks in Europe, this is entirely run by hydrogen fuel cells, has zero emissions, and clearly it is doing the activities with lightweight batteries, because if you take up all the battery weight, the airplane will have no payload. You can't sit in it, nor you can put any cargo in it. So this is a small step towards a big goal of how do we get towards a carbonless environment, which is going to be the world. Everybody talks about climate change. Everybody talks about the effects that are happening on the world due to the climate change. You saw how the weather was in the United States, almost severe that ever seen. Just last week, they had another snowstorm. So these are important things, and it paves the way for use of fuel cells, which are emission-free, but also it is creating a secondary source of power in an airplane if there was a double engine failure or something of that sort. So again, important research and moving in the right direction in a collaborative manner. Air traffic management. We are working with Jeppesen and DLR. Jeppesen is a Boeing company. What we're trying to do here is, can we save millions of gallons of fuel around the world if we come up with ATM type, that's air traffic management systems, that are going to be optimized, that can relieve the congestion, and that can integrate ATM with the airborne technologies. FAA has already started the next generation air traffic management system. We are participating with them, and few airlines are participating, and we're trying to see if we can bring and decongest the air traffic control area when we come into a terminal area like Bangalore Airport. And can we bring these airplanes down fast? Can we minimize the time it takes down? Our analysis shows that initially, if you can do something like this, you can save about 12 to 15% of carbon emissions just by optimizing the way you approach when you come to the terminal areas. Biofuel, another very important area to help with the carbon emissions, and that is Sustainable Aviation Fuel Users Group has been formed, and what you see, all the logos, all the airlines, and below are the companies who are involved in making sure that this becomes practical. Several flights already have been conducted with the biofuels. However, today the scale is not such that airlines can take the biofuel and start doing it as a regular way of doing business. The reason being, the ATF, aviation turbine fuel, is about $4 to $5 a gallon, depending on where you're looking. Biofuel can cost anywhere between $30 to $40 a gallon, and not where you can really do it. So you can do experimental flights, but when the scale goes up, the biofuels will come in handy. Another key challenge the mankind, meaning all of us, have is to make sure that the biofuel do not create a food shortage or shortage of any other kind. So sure, you solve the aviation problem, but now you created food inflation or food security problems for the world. And that happened with the corn, as some of you may be aware, in the past. Now, India has an amazing track record of innovation. Having born and brought up in India and educated in India, I'm proud of the legendary things that you see here, right from the Aryabhatta 580 to the designs of Ellora and Ajanta caves that have been done in thousands of years ago, before any technology that we know as we know today existed, or Sir C.V. Raman or Srinivasa Ramanujan. But that innovation now is continuing by the Aryabhatta satellite that we had in 1975, the wonderful way you cross now from North Mumbai into the South Mumbai, and then the Nano, which itself is an innovation with the cost and what it has achieved for a common person, and then the Chandrayaan-1 that was obviously instrumental right here in Bangalore. All these are innovations that are Indian originated, and obviously there is abundant talent here, and that needs to be harnessed and integrated into the world base of technology. And so if you look at how we're doing this, within India, I won't take time on this chart. We have so many places we are doing collaborative research. I just want to show you. And the way we work in this is we have focused, we decided rather than working in every technology in every country, let's focus where the key technologies of India that we can partner with. And we figured out materials and processes is one such thing, and you can see the logos of the entities we are working with. Manufacturing, which is going to be key, and you heard that earlier from Mr. Mahindra. Aerodynamics and analysis. A lot of talent here, a lot of computing power there, and I'll show you examples of some of these, and I'll conclude my talk with that. Network systems, another important area, and software, which nobody has to be told in this audience that India is leading the way. And these are the opportunities that I have listed here that we can gain for the world, not just for India, by working here. So if I look at one example here that we are doing in Indian Institute of Science, Bangalore, and that was the boron-modified titanium alloys. We took the titanium alloy and added some boron in it, the 0.09% as you see, and it is helping us in the future to reduce the cost of the titanium 64 alloy. It can be used in aircraft application, and I'm pleased to tell you that with this Boeing-sponsored project, we already have the first Ph.D. granted at Indian Institute of Science in Bangalore. And that is the kind of research we want to do here, materials and metals, very important, and a lot of talent right here in Bangalore. The next example is computational fluid dynamics. We are working with the Tatas on this with ECA Computer, which is Computational Research Laboratories. And we gave them the detailed studies of 777 in a high-lift configuration, the high-fidelity studies to understand what CFD can do to accurately predict wind tunnel. I mean, I did my PhD in 1978, and the issues are still there about how we connect the fidelity of wind tunnel with the flight test and with the CFD models that are predicting it. That quest will, in my mind, never be over. We're getting more and more accurate as time goes. 30 years have passed, but I think the technology still needs to be there, and it helps the technology to do the high-lift system design, which is so important in the modern aircraft, and particularly the fly-by-wire technology that is coming into the aircraft now. The radio frequency ID that we are working with IIT Kanpur. Simple but very crucial, and I'm sure you're aware, many of the airlines today are using this technology When you check your baggage, they put the RFID tags on it so they can kind of keep track of where that piece of baggage went, because millions and billions of baggage annually go through the system, and you know how uncomfortable and inconvenient it is when a baggage is lost. Similarly, if you are in a factory like Boeing, which is 96 acres, it's a huge factory, and if you have tools that are expensive and you can't find them, it's very expensive to get second set, and that may be lying somewhere else in the corner. So all you do simply is put the RFID tags on that tool, and you go into the computer, put that tag number, and pretty soon you will know where in that whole facility that particular tool is sitting. Fairly inexpensive. The technology has come, and we are working with IIT Kanpur and students there to see how we can improve it, make it more perfect, and it will also help us to do the just-in-time delivery of parts and materials, because as we do the moving line of production of the aircraft to reduce cost, this is one way you can get the right kind of things at the right place. And it will also improve our asset utilization that's in the factory. The final example of research that we are doing in a collaboration manner in India is right here with National Aerospace Laboratories, NAL. And what we are doing there is we took a rudimentary landing gear, we defined it, and we took that gear and give it to the NAL folks. And with that, they have now developed codes, and they're studying the design of that landing gear. And by doing so, we are trying to see how we can do a better gear that reduces drag and the noise. That is the biggest problem we have, because what does the gear do when you put the gear down? It creates a lot of drag, but you need it to land, and it creates a lot of noise. So if you can improve that design with the CFD and other technologies, it's going to help. So what you are seeing here are some of the photos and examples that they're doing in the wind tunnel right now with that gear, and then we are trying to, as I mentioned earlier, correlate that with the CFD codes and thereby also develop the better CFD codes. All this is bringing not only technology together, but improving things that are needed for a regular day-to-day life type approach that we all do. Now, I have a couple of charts left now to tell you why do we come up with technology? What are the main drivers of technology? And I'll submit to you there are 4 fundamental reasons why people are wanting to get into technology. One example is extreme affordability. If you go back and see the cell phones, we were paying 16 rupees a minute. Now we don't pay even 1 rupee a minute. That's making it affordable. Similarly, the computers, when they first came out, even this little laptop was, the computers were not even powerful as this little laptop, but now not only the cost has come down, size has come down, but also the performance has gone up. So extreme affordability is one item. Environmentally progressive. We talked about biofuels. We talked about no carbon emission. As we get into more environmentally oriented activities, we are going to find more and more technologies needed to meet the needs of the world and meet the needs of the society as we go forward. Breakthrough performance. We may want to do things in terms of range, payload. Just a few years ago, you couldn't fly non-stop from India to US. Today, you do that every day. That's increasing the payload, increasing the range, increasing the mission effectiveness, reliability. All these things make you do breakthrough performance and will ask you to do more research in those areas. And finally, the enduring sustainability, meaning we want to basically modify, create an open architecture, something that's easy to upgrade as the next versions come up, just like the software codes do, but I'm talking about hardware now. These are the reasons why we get into technology development. That's why anybody would want to invest money in R&D, and you can see these are good reasons. So in summary, as the systems will become more complex, collaboration and teaming are the only way of the future. And I was really heartened when I was sitting there listening to Mr. Mahindra. He feels the same way. Mahindra, as I heard from him, is getting in a big way into aerospace research and technology. Clearly, this is an important facet that we believe in also. As I've shown you clearly, India has a great history of innovation, and we are well positioned to get into the significant contributions we can make for further advancing aerospace. And as we spend next 4 or 5 days right here in Bangalore for the Aero India 2011, you're going to see a lot of real examples of flights, a lot of real technology type thing. And in this very seminar, I'm sure you're going to hear about breakthrough technologies and how things are happening in the world today. And finally, Boeing is already working with Indian technologists. We are really proud of that, and we look forward to the continued collaboration. And while it is not part of my topic, I heard Mr. Mahindra say one more thing I'd like to comment on it, and that's offsets. Clearly, offsets is a big thing for India. As India buys a lot of big-ticket items, particularly the Ministry of Defense, obviously India is going to get something back, and these offsets are going to create an aerospace ecosystem that is going to make India indigenous someday. Sustainable technology is going to be part of that, and we as Boeing commit that we'll be part of that. So thank you very much for listening and giving me this opportunity.